All right, so say we've got some data. One of the things we want to be able to do is display this data in a way that's easy for somebody to recognize, to understand, and to work with. Now, I got a list of data here. The first thing we want to do, of course, is put it in order. Makes it much easier to deal with. So if you have data that's out of order, put it in order before you start worrying about any of this other stuff. Now, this set of data, which represents nothing, is very easy to understand. There's only a handful of numbers and you can process them all fairly easily. But suppose you had 3 or 4 times as many numbers or even more than that. It's going to be difficult to look at that and understand exactly what that population of numbers looks like. So what we want to do in a couple different ways is to have graphical representations of the data. And the easiest one, I think, is the dot plot. The way we do a dot plot is we start with a number line. And that number line has to be indexed, meaning we have to have marks and numbers along it to see where each of the numbers are. And it has to be indexed correctly and consistently. Okay, so we wouldn't do this. Okay? I wouldn't say, here's a mark for 1, here's a mark for 2, here's a mark for 3, here's a mark for 5, because that's the number that I have next. And then there's 8, and that's 12, and that's 20. You wouldn't do that. You need to have the numbers spread out as they would be on the number line, because that will show us that, the 12 and the 20 are much farther apart than the 1 and the 2 are. We want to see that in our line. And once you get the number line, it's indexed, right? If I've got numbers that go from 1 to 20, my index needs to go from 1 to 20. We can then just go ahead and put a dot at each number. So we have a number 1 there, we have a number 2, we have a number 3, and then 5 is here. We have 1, 5, and then another 5. So we're going to stack them up like that if we have multiples. And then 6, 7, 8 here. And then we've got 12, 12, and 12. And then we've got a 20. Okay, and we can see now, just by looking at this, that we have our little cluster of numbers down here. We've got, for some reason, a collection of 12s there kind of in the middle. And then we got a big gap between that and this guy out here, which we'll talk about later, is called an outlier because it lies sort of outside the range of the data. Okay, so number line indexed evenly. So each of the numbers are in the correct place like they would be on the number line. And then dot for each member of the population. If we have multiples, we stack those up, and that'll show us clusters and gaps, which are going to be important things in the data, right? Just looking at that, it doesn't necessarily jump out at us that 20 is pretty far above the next number there. But looking at this, we don't even have to think about it. There's a huge gap there that we can see. Okay, that's what good a dot plot is for us. Now, reading one, I want you to be able to create these. I also want you to be able to read them, is really pretty simple, right? If you were to look at this dot plot down here, you would know that this represents the data. There's a single 20 there, and then each of these marks is going to be 2, right? So that's going to be 26. So there's 2 26s, and then we've got, that's 34. We've got 3 34s, a 40, a couple 56s, and then, 46s, right? Those are 46s. And then we've got a 50 at the top. Okay, so I'm pretty sure if you understand how to create a dot plot, you can certainly read one. So that is dot plots, really about all there is to them.